let's have a look at 1 first. Now, the first thing I'm going to say is, if question 1 were a multiple choice question, okay? If question 1 were a multiple choice question, then this would be one of the answers. This would be A, B, C, or D, okay? Has anyone got a different answer to it?
Yeah, I got it.
Okay, now a half would be another one of the answers, okay? When we provide multiple choice solutions, what we try and give is what's pretty close, like we don't try and like randomly guess out numbers that like you would never get. What we want is to introduce like 1 error or 2 in there and then use those as our solutions. Now x equals 2 is so very, very close. Okay, let's just have a look at this line by line. What have we done to go from the first line to the second? What has been done to both sides?
Both sides by 2 to
Great.
cancel the fraction.
Fantastic. So we wanted to get rid of this, which is a good move. So multiplication by 2 will do that. Okay. So far, so good. Line 2 to line 3. What's been done?
You add 10 on this.
Expand.
Okay, I think there's expansion, right? The left-hand side has not changed. It's just the right-hand side, and we wanted to get rid of the brackets. Why is getting rid of the brackets a good idea? Because where are we trying to go? What do we want our final line to be? We want it to be x equals, right? Except there's like x's tucked in there that we need to get out of there, so therefore we expand. That makes sense. Is that the correct expansion for this line?
Yeah.
Yeah, good. We've doubled that. All good. Okay, this next line's a bit tricky. A couple of different things happen. What are the 2 things that happen?
You add 10 from the x.
Put the x's to 1
and then
side.
for the plus 1 to the 6.
Okay, so you can say this in a couple of different ways. You could talk about moving the 10x over there. Even though that does work out, I prefer to say I'm adding 10x to both sides because it's an equation, right? We want to do the same thing. That does give you 14x. And then in the same way, we add 1 to both sides. And that does give 7. So we're all fine up until here, okay? Now, how does 2, don't tell me whether it's right or wrong, how does 2 emerge from this line into this line? What would you do to get 2?
Divide by 7.
You would divide by 7. Now that's a common thing to do because when we think of division, we usually divide big numbers by small numbers. Usually. But should I do that in this case? No, I actually, and this is, I should divide by 14. So let's actually just add that in. If I divide this by 14, that'll give me an x. If I divide this by 14, I'll almost get 2. I'll get a half. Do you agree? Okay, so you see why, like, so much has been done right, and it was very close. But you've got to be careful with little solutions like that. One last thing that I knew before I actually didn't know what the answer was when I wrote this down. One of the ways I could look at that and instantly know something was wrong is because if I just take 2, and just have a look at what it might be up the top. Okay, now I don't even need to know the values. Over here, right, 3 take away 5 times 2. That's going to be a negative number, right? I don't know what it is, but it'll be negative. Okay. Over here, 4 times 2 minus 1. That's going to be positive. You divide by 2, it'll still be positive. So there's a mismatch. I don't even need to know how much of a mismatch it is. I just need to know that it is one, so that makes me reinvestigate it and say, well, where did something go wrong? Okay, and that's why our working is so important. Thumbs up? Make sense? Okay, can I get a suggestion for the volume? Anyone want to be brave? Stick their hand up. Yeah, Liza?
I just worked out the...
Do you want to give me the number, and then we'll go from there.
So I did pi times 6.
Have you approximated it? Have you gotten like used the calculator and said equals? Yeah, the actual.
Oh, you want me the number? 1130.97.
1130 point.
I didn't get
Point what?
Oh no.
Something different?
I got 2000.
Do I want to get a different answer?
I got 2010.6.
Do I get more agreement on that one?
I
We got all different answers?
Yay!
What did you get, Ash?
1005.3. I got that.
How many got that?
I got that.
Okay, we got a few hands up. Alright, let's confirm. So I posed this question. I posed this question to everyone, and it's a bit sneaky. I said, if you had to pick a shape that this was closest to, what would it be? And you could take the cylinder, like the big thing is a cylinder. But maybe an easier way to think about it is it kind of fits just like all of the other prisms that we've looked at, right? What makes a prism? Do you remember?
If you cut down its cross section.
Yeah, good. So if I slice across and get the same shape every time, what do we call that shape, by the way, if you slice across? We call it a cross section, right? Because that's what actually section means. It means cut, and cross means across. So you can see if I cut all the way across, what would you get, by the way? What would you call that? you kind of get like yeah, sort of a donut. This disc sort of thing, it's actually the special name. I don't know if you remember, I gave you this a couple of terms ago. It's called an annulus. Okay.
I like that one.
So you get one of these every single time. So I can treat this as a prism. Therefore, here's one way I could work out the volume, right? I could say, what's the area of the cross section? That's the important part. How do I work out the area of the cross section? Yeah.
You work out the area of the top bit, assuming the middle hole's not there, and then you figure out the area of the middle hole and you minus it.
Okay, good. So there's two circles up there. Yeah, there's two circles. So one of the circles will be pi r squared. What's the big radius that I'm going to use?
6.
It'll be 6. And then I'm going to take away another pi r squared. But what's that pi r squared? It's going to be 2 times 2 squared, right? Okay, so that'll give you that, whatever that happens to be, that's your cross section. Okay, and then I multiply that by the
10.
height. And you can check if you get that. Eliana.
I took it as the hole in the middle.
Yep.
The only empty part until find the volume of that. So I thought the thicker circle was filled, right?
Yeah.
And so we couldn't figure out the volume, but the only thing, like it was a disc. So
Yep.
somehow it's thick on the outside, just that little.
Yeah. So we're gonna come to the same answer if you've punched your numbers correctly, because you'll do the big cylinder, right? And then you're going to subtract the cylinder in the middle. So it amounts to the same thing. So you should still arrive at 1,000.
I didn't figure it out just so.
Oh, you only did the inside part?
Yeah, because I thought that's the only place where you can carry stuff in. Like
That's a fair.
So you're asking about capacity, how much stuff can I fit inside a container, versus volume, which is how much space does the container take up.
Okay.
Does that make sense? So those are very closely related questions, but different. It does look like a polar. I realized that as soon as I drew it, I was like, oh, okay. All right, now surface area. Do we have a number for that? Who wants to be brave? Yeah? No. Chris? 7?
703.7.
Okay. Do I have some agreement on that one? Yeah. Thumbs up. Okay. Hands down. Now, just before we leave this, because I'm happy with that number too, it looks about right. What is this number composed of? Like, what are the pieces that go into this? Okay. How many areas do you count that make, if you had to like count them up one by one, that make up this surface area? Do you count 4? I count 4 as well. You got the top and the bottom, which are the same. Okay. Then you've got the outside and the inside. Does that make sense? Okay. So the way you're going to do that, let's do the top and the bottom. The top and the bottom is going to be this, isn't it? Like we actually already worked this out. The top will look like this. Now, the top and the bottom are the same, so I'm going to double that. Do you agree? Okay. And then I'm going to have to add the 2 ones that are missing are curved surface areas, aren't they? So I've got a 2 pi r h for the big one and a 2 pi r h for the small one. What would that be? 2 pi r h. That's the big one. And then this small one is 2 pi r h again. Okay? And then obviously you crunch those numbers with your calculator and you're done. Okay? Are you happy with that? Does it make sense? Cool. It was asked, like, is this the inside? Is it the outside? If you're not told anything, you should do the whole lot, including whatever's inside, okay? They should be clear for you, but if it's the total area, they often won't say anything at all. Okay, would you please rule that off? By the way, I was really pleased that I saw a lot of you in your diagrams. They were good sized diagrams. I saw you break apart the shape into the different components, which was big thumbs up.